In this video, we'll be starting with a linear function, f of x. We'll find its inverse function, f inverse of x. Then we'll look at the composition of these two functions. Start by creating a Desmos window. You may want to log in. Graph y equals x, which is a line that crosses the origin and has a slope of 1. The reason for this graph is that functions and their inverses are mirror images across the line y equals x. Now we're ready. So let's start by graphing the function f of x equals kx. You'll be asked if you want to create a slider for k. You do, so click the blue button. By default, k equals 1, so change the value to a value greater than 1. Change it to 2. The slope of this line is 2. You can see that it's 2 by counting up 2 and 1 to the right, and you're back on the line. The inverse of this function would have a slope that for every 1 up and 2 to the right, you would be back on the line. In other words, the inverse function would have a slope of 1 over k. So create function g of x equals 1 over k times x. G of x equals 1 over k times x. Do you see how these two lines are mirror images of each other across the line y equals x? Change the value of k, and you'll see that the lines continue to be mirror images of each other. That means that they are inverses of each other. So what do you think the graph of f of g of x would look like? Let's graph it to see. Input f of g of x, and you can see that the graph of it is identical to y equals x. Now look at g of f of x. It also has the same type of graph, overlapping y equals x. So the function f of x and g of x are inverses of each other. In fact, you can write g of x this way, f inverse of x. The one exception is when k is equal to 0. So change k to 0. Notice what happens. The graph of f of x is this flat line that overlaps the x-axis, but there is no graph for g of x, which would otherwise be a vertical line. Why? Because 1 over 0 is undefined, and therefore g of x is undefined.